Okay, good morning, good afternoon, everybody, and welcome to our live webinar today, our session where we're going to be talking about uh, some cross-platform threat hunting using mobile IOCs and other indicators of compromise to help discover and figure out the full breadth of an attack and also learn about new malware. We're going to be using some pretty cool examples of things that we found here at Lookout to exemplify sort of the importance of this. But before we get started, my name is Hank Schless. I'm the Director of Product Marketing here at Lookout, and I have the distinct pleasure of being joined by two of our researchers. We have Christina Balaam and Parth Bhatt here with us, and we're very excited to have them alongside. So as we mentioned leading up to this, the goal is really for this to be an interactive session. We're going to try and keep it to about 30 minutes, and really decided to focus on this topic because, as Christina and Parth will take you through, we're seeing more in sort of these coordinated cross-platform attacks as APTs, but also advanced cybercrime groups that aren't necessarily backed by nation states are looking to target, both adversarial nation states, but also more importantly, for many people, more importantly, the enterprise. Now, I think it's fair to say that everyone's probably recognized an increased importance in the mobile side of that, especially as things as simple as mobile phishing attacks have become more prominent, but also seeing more news around compromises that really use mobile devices as a key part of sort of that modern kill chain. So as I mentioned, we're going to kind of cover three key parts in this webinar. First, we're going to talk about excuse me, the sort of cross-platform IOCs, indicators of compromise, that Christina and Parth were using when they originally discovered WyrmSpy and DragonEgg, which are two pieces of Android surveillanceware developed by APT41, which is a Chinese nation-state group. We're then going to talk a little bit about how you can really interpret those mobile threats and how they could put the organization at risk. And then kind of finally, just a little bit about how mobile EDR can really, help strengthen security workflows, really fill that gap that a lot of tools and teams have, and really help keep your data secure. For those who have not really interacted with Lookout before, just a quick overview about us, and we're intentionally doing this without slides because everyone's sick of slides. But Lookout was founded back in 2007. So we were actually the first mobile security provider to market. We started as a consumer Android security company. And then a few years after that, once traction picked up, we decided to move into the enterprise. And then we've evolved since then. So in that time, we've really gone from, we were originally kind of this small consumer company, and then we actually sold our consumer business a few years ago. We are fully focused on the enterprise, and we're offering mobile security for small businesses, enterprise, governments, everyone in between. One of our biggest differentiators, and really something that helps enable such a skilled research team, is that we have the largest mobile security data set. So because of the nature of how long we've been around doing this, we've got telemetry from over 225 million mobile devices and over 330 million mobile apps, which obviously that telemetry helps feed the research that Christina and Parth's team does. From the threat intelligence side, we do have that data set. It is AI driven, and we've been saying that since well before this AI boom. That's really been something that we've implemented since day one, kind of across our stack, and has really helped drive some of that more kind of predictive analysis to identify and mitigate threats, backed by this awesome team of dedicated mobile security researchers, of which Christine and Parth are members, excuse me. And then finally, we really started to expand our offering about 3 years ago, moving more into the world of data protection on top of our mobile security offering. Basically, what we looked at is seeing how data really has become the most valuable asset for any company, and how much of that data moved to the cloud. We did move into the secure services edge industry as well, understanding that employees use their iOS, Android devices to access this sensitive corporate data from anywhere. And the best example of it really is, we all use our phones. I used it to log into my MFA this morning when I logged in. They really are the keys to the kingdom. So being able to not just secure the device, but also have the solutions in place to secure that cloud data, the access to it. All that goodness as well is really where we've been evolving. So that's enough of me talking. Christina, I'm going to hand it off to you to kick things off. And again, please, for the audience, please do ask questions throughout. We'll do our best to answer them. If we don't get to any of them, we'll be sure to follow up with you afterwards, but please do throw some questions in there. So Christina, take it away.
Great. Thanks, Hank. So I'm going to share my screen here. And as Hank explained, we're going to walk through an example of how we uncovered some really interesting mobile surveillance applications tied to APT41. So we're going to start by looking at this indictment document. This was released by the United States government, basically detailing the indictment against APT41 and specifically a number of individuals who were identified as part of this threat actor group. This is an interesting threat actor because although they are associated with state-sponsored activity, espionage activity, they are also often encountered conducting financially motivated crime. So we don't often see this with state-sponsored actors. We often kind of see them sitting in one of two camps. Either they're really conducting surveillance operations on behalf of whatever state is sponsoring their activities, or they're kind of part of like a cyber criminal organization. So APT41 is kind of unique in some ways. And also we don't typically see these kinds of documents being released from various governments, really detailing the operations that have been investigated. And certainly we don't typically see identifying details about the individuals involved. So this is a fun one to kind of pivot from because not only are they a very well-known threat actor and very prolific, they've been involved in a number of different operations targeting something like 100 different countries or slightly more than 100 different countries in different industries, video game industry, public sector departments, education, kind of all over the place. They've sort of dipped their toes in cyber criminal activity everywhere, as well as espionage activity. But we also don't typically, get a whole lot of information about all of the investigation into their various criminal activity over the past. So we're going to pivot from some of the details that were shared in this indictment document. And we're going to use it to look at how we uncovered two different malware families that we have tied to APT41. Now, again, this is pretty exciting because we also this is like a great example of multi-platform or cross-platform activity from a threat actor. Again, we don't always see this. We're seeing a significant increase in the number of threat actors who had primarily targeted, say, desktop with malware, and now they've realized how important it is to also target mobile devices. So we are seeing a significant increase in the number of threat actors who are pivoting to mobile or who are launching these cross-platform campaigns. But this is like a really great example of really tying the threat actor to the various tools that they have released. Because as we all know, attribution is very difficult. So when you have the smoking gun, it's much easier. So we're going to look through this document here, and I'm going to hop right to where we're getting. We're looking at a particular piece of infrastructure that was attributed to APT41, this vpn2.ubsen.com subdomain. So this was interesting because it was actually used by the threat actors to access their internal corporate infrastructure. And this is part of what we use to be able to find mobile surveillance tools that were connected to the threat actor. So in a case like this, when we have IOCs that we want to see whether they have any like mobile component, this is typically what we do. So we start with a subdomain like this, ubsen.com, the top level domain, or a subdomain like VPN2. And we're going to hop over into VirusTotal here, which is a handy tool for seeing what resolving IP addresses were tied to this infrastructure. So within our tool, it's helpful to look for both the subdomain or domain that we want to investigate, as well as any IP addresses that might have been connected to the threat actor at that time. So if we type in ubsen.com, we're going to hop over to this Relations tab, and we can see 3 different resolving IP addresses that are connected to this domain that was referenced in the indictment document. So one of the first things we want to check is that the IP addresses are unique, like the hosting is not some sort of shared hosting where perhaps a number of different users were accessing the servers, and so it makes it much more likely that you'll come into a false positive situation if you're looking for any kind of malware that was communicating with this infrastructure as a command and control infrastructure. So let's hop into each of these IP addresses and see what we can learn about them. Okay, so 123.206.51.93. This looks pretty promising. As we can see here, there are only 3 connections all to UMISEN, or like some variant of UMISEN. This 121.42.149.52, we can see here as well, we're really only seeing 1 domain name associated. That is promising. And then here we have 50.63.202.57. And this to me looks like shared hosting. If we kind of continue loading all of the various domains that are associated with this IP address, we see a whole bunch of random stuff. So this to me looks like it's probably shared. I wouldn't really look for anything communicating with this IP address because it's very likely that we're going to run into false positives. So let's ignore that one for now. Now, of course, it's going to have to be signed back in. We're going to hop into our console.
All these security companies requiring MFA, you know?
All right, I'm back in. Okay, so this is what our mobile endpoint security product looks like. We have a dashboard here, and we're going to hop into the research tab. This is going to let us query against our data set for various indicators. We can search for things like, strings that are found within a particular malware sample. We can search for various capabilities that a malware might have. And we'll look at some of that in the next little bit as well. But what we're going to start with is using the indicator that we saw from the indictment document, that umisen.com domain, as well as the resolving IP addresses that we just encountered, and try and see what within our data set is actually communicating with this domain and the IP addresses. So we can do that in a few ways. The first way is going to be looking for actual string representations of the IP address. And you might notice now that we have a handy autocomplete function in here, which makes our lives much easier. So we're going to start with the first IP address that we saw. IP address is .address, and we'll look for that 123.206.51.93. And now I also want to hop in here, and I want to go back to umisen.com and double check what that VPN to umisen.com resolving IP was. Okay, so let's add a third one in. Let's take a look at this one as well, 171.221. If we hop into the relations tab for this guy, there's some interesting stuff going on, but not a whole lot of other connections. So, it seems like it's probably a safe bet let's just see what's also communicating with this. So again, IP address is .address, and we'll put 171.221.254.252. So we've got those 3 IP addresses. Now, actually, what we should be doing here is combining these with OR. So we want to see basically any samples that have these IP addresses hard-coded in their in the malware, source code, any of them. Anything you have, please show us if it's related to these. So now we're going to look at any communications with this infrastructure that we've observed dynamically. So we have this engine called Dyna. That's what we call it. It's a dynamic analysis engine. And essentially what we have is an emulator that communicates with the samples that we ingest and looks for things like network communications, our additional payloads acquired from the malware, what kind of access rights, or is it trying to be granted on this emulated device, basically as if you were running the malware on, say a compromised device. What would we expect it to be doing? And then we get a nice little summary of what Dyna has experienced. So as part of that, we can look at communications between the emulated device and the malware and any connections it's made to its C2. So we'll start with dynamic sessions, and we're going to say IP flows for the IP address, destination, 121.42.149.52. And again, we want to see anything it has. So we're going to combine these with the OR query. And 123.206.51.93 or dynamic sessions.ipflows.destination 171.221.254.252. And then last, but certainly not least, we want to look for the actual umisen.com domain. So this is again part of the dynamic sessions query, but instead of saying IP flows, we're going to say observed resolutions and look for QName. Oops, QName. And then we want anything that's like, a subdomain of umisen, basically anything tied to umisen.com. We want it to report back to us. Okay, so we have our string search for IPs. We have the actual dynamic analysis results as well as the domain here. Okay, so let's hit search and see what we get.
So I'm going to take this opportunity to give you a sec, Christina, but also Parth, we had a question come in that I think I want to throw over to you because I know you do a lot more kind of the strategic threat intelligence stuff as well. Folks were asking just about sort of the historic targeting by APT41, some of their, some of the tactics we've observed or have been known. Someone just said, when I saw Christina go into that indictment, it looked pretty interesting. Can you offer some more insight into their historic activity? So maybe a little bit there from you, Parth.
Sure. So yeah, I mean, some of it Christina covered around the 100+ enterprises targeting that was mentioned in the DOJ indictment. And they have been known to be active since at least 2012. So it has been around 12 years now. They have been active in this Chinese state-sponsored activity space, and they are carrying out multiple different types of attacks against private and public organizations, so nation-state governments. They have also been known to target telecom enterprises, software development companies, hardware manufacturers, and definitely video game companies. Which is the interesting part as well. They apparently they also, as Krishna also mentioned, they also perform some financially motivated activities, which is around these type of companies, which is mostly around their personal gains, and then the state-sponsored activities. So yeah, they have been they have actually targeted almost many of the continents around the world. So actively targeted Southeast Asian countries, United States, definitely, as you can see the US DOJ indictment there, and European countries, United Kingdom, France, and others. So since the beginning, they have been using lots of backdoors and random access trojans to remotely control the victim devices. And originally, they focused on traditionally they have been focusing on traditional endpoints like desktops and servers, and so installing backdoors and installing random access trojans or remote access trojans on those devices. And the motivation behind this is they have been doing a lot of theft of source code. They have stolen code signing certificates from these companies or enterprises, and they have also stolen customer data, personal identifiable information, and they have also been known to perform many supply chain attacks. So basically, trying to do a computer intrusion or hacking into one company so that they are able to reach protected computers of another company, for example. And so yeah, since and they have also been known to target like NGOs, energy companies, and some of the crypto mining activities as well, which would, I would say, again around the personal gain side of it. And yeah, right now the activities that Christina is mentioning is around espionage, because these are like Android surveillance wares that we are talking about.
Awesome. No, that's super helpful. Sounds like they kind of just go after about anyone they can. But cool. All right. Thank you, Parth. Christina, back to you now that you've had a chance to breathe for a second.
Thanks. Cool. Okay, so we've run our query and we have 19 results here from our data set, which is pretty exciting. I mean, we can see here that we have convicted these samples as WyrmSpy. If you've read the public reporting we have around WyrmSpy and DragonEgg, you'll know that we have attributed this particular surveillanceware to APT41. So because we've already convicted these samples, we see the detection here under threats, classification, that kind of thing. So we have the threat, WyrmSpy, the classification, surveillance. However, back when we were first making this connection, these all came back as undetected samples, which was very exciting for us because it was really the first time that we'd encountered mobile, mobile surveillance tool from APT41 in our data set here. So now what we can do is we can hop into one of these samples and learn some more details about it, as well as see whether we can find any additional samples within our data set that might be connected in some way beyond just this connection to infrastructure that we know is tied to APT41. So let's hop into the
Christina,
sample here.
real quick, I just want to jump in
Yeah.
on one thing there. Just for you to clarify. Even though, so I know you said it was undetected, but it would still show up as in that risk exposure column. It'd still be like, hey, this is a really bad thing. We would still
Yes.
protect against it. It just wasn't classified as a specific named piece of malware yet, right?
Right. Yes.
Okay,
good clarification. Cool. So yeah, it just wouldn't have a name. You would still see that this was really bad. You shouldn't have it on your device. You just wouldn't see, the name WyrmSpy here in the console, for example. So if we hop into this particular sample, we get a bunch of details about it. So we can see where it was acquired, when it was acquired. We can get some information about the metadata, what the title of the application is, what it's pretending to be. If we hop into behaviors over here, we can see the various capabilities that it has. Here we can see the named assessment, the threat that's associated with the sample. See here we have WyrmSpy. And then we can see more capabilities that we can actually pivot from within the console to search for other samples that are perhaps trying to do similar things on the device. And we can look at what that kind of query looks like in a moment as well. It's pretty interesting with surveillance where we tend to see the same kinds of capabilities. We see things like reading contacts, receiving SMS, reading location. A lot of the times we'll see something, contains dynamic code and records media, accesses camera, really the most invasive permissions and capabilities you would expect on a device. Where it gets a little complicated is that many social media applications that have, completely legitimate reasons for requesting access to these capabilities from your device also request the same permissions and capabilities. So it's trying to figure out, the sample that you're looking at, does it have a reason to request access to these things? Is it doing what it says on the tin, or is it perhaps trying to get you to just grant access to more capabilities from your device than it really should have access to? So something to keep in mind, and we'll look at how we can pivot from that. So we're going to hop into the metadata here. And in this section, we can actually look at the signing certificate that was used by the developer to release this application. So a signing certificate for Android applications is kind of like an identifier for the developer. Now, sometimes you'll see samples that were signed with a debug signing certificate that really doesn't identify anything about the developer. It's used by a number of different individuals or organizations, and so it's not really a great pivot point. Sometimes you'll see a sample that has actually been compromised. So, somebody's signing certificate is, a bunch of different people have access to it that really shouldn't have access to it. But in this case, we're looking at something that looks pretty unique. Now, we don't see any identifiable details about who the person was that actually generated this certificate, but we can pivot from here and see if there are any other samples that were actually packaged with the same signing certificate. And that's a pretty good indication that that application was developed by the same actor who, packaged and released this WyrmSpy sample. So we're going to pivot from this hash here, the SPKI or spooky hash. And if we just click right on it, it'll take us into a new query within the research console. Okay, cool. So now we can see here, we have a whole bunch of WyrmSpy samples. That's expected. Most of the time, a threat actor operates very similarly to your regular software engineer or software developer. There tends to be kind of like a life cycle on malware, and they'll reuse signing certificates or infrastructure or source code throughout different variants of the malware that they have created as part of like an iterative development life cycle. So this is to be expected. Now, what we're looking for is something like this right here. So we see a whole bunch of WyrmSpy, but now we see a slightly different application. This one has been convicted as DragonEgg. If we open up this sample here, this gives us a really good idea of another sample that is not part of the WyrmSpy family that is almost certainly developed by the same threat actor as was responsible for WyrmSpy. So this is a great way to pivot between samples within a data set to see, okay, we know that APT41 is connected to these WyrmSpy samples. What else have they done? And a signing certificate is a great way to make that connection. Because again, like I said, if you have something that's compromised, a certificate that's been compromised, most of the time that information has been publicized. You're able to figure out if it's a compromised key. Otherwise, it's kind of like a fingerprint for the developer. And so it's really great to be able to see that, okay, they have more stuff out there in the world that they've developed. And we can pretty conclusively say that. So here we have this DragonEgg sample. And what's interesting about this particular family compared to WyrmSpy is DragonEgg really relies on secondary payloads. So you have a core application, and this is quite common in mobile malware. You'll have a core application that maybe has some surveillance capability, or it might seem totally benign, but it reaches out to its command and control server and downloads additional payloads of dynamic code that allows it to perform more surveillance functionality or do more malicious things on your device. And DragonEgg is a great example of this. So we can actually look for samples that have this payload that our DYNA, or dynamic analysis engine, has acquired through that dynamic analysis process. And we can do this by hopping back into our research console. And we can look for DragonEgg specifically, since we know that these samples have a name, code family versions, and we're going to say family.name. This is the specific query, and we're going to say DragonEgg, show us everything that's detected as DragonEgg. But we also want to see samples where DYNA has acquired those secondary payloads. So we're going to say dynamic sessions, and you'll recognize this from the search for infrastructure, artifacts, label, and we want something that says dynamic code, as well as we want artifacts that have a content type of application Dalvik VM. Okay,
I have two questions. This is a good spot for the queries are always a good time because they do take a sec. So the first one is about shared sort of shared development, shared tooling, shared artifacts. So the question is, and Parth, again, I'll give this one to you. Christina mentioned that a lot of this is like a standard software development lifecycle. I know that a lot of times we all go in and find code from other tools or open source solutions. Do you often see similar activity from APT groups who are reusing malicious capabilities that other malware developers have used? Long question, good question, but yeah, how often do we see that?
Actually, it's quite common, and as the name APT suggests, right? They are advanced persistent threats. So persistent means like they have to continuously evolve and be persistent in the environment, and which might include like they have to continuously create new campaigns, or if they lose access, for example, in an environment, they need to create new campaigns, and when they have to do it very quickly, they will definitely end up reusing some of the components of the malware. So, I mean, in case of like ABD41, it's well known. They have been reusing components of their own malwares across campaigns, and also sharing some of the components with other APTs as well. It's quite documented in reports from different vendors. And so, I mean, sharing, as I just mentioned, like sharing of malware components could be sharing across different campaigns by the same APT, or different malware families by the same APT, like the one Christina is just showing. That is like the WyrmSpy sample has same signing certificate as one of the DragonEgg samples. Or it could be like sharing across multiple APTs, right? So multiple APTs using same sharing some piece of component of a malware. So, and these are like actually very interesting points for a threat hunter, because you can then pivot through a data set, and when you have identified one piece, then you are able to pivot to another, or other groups or other campaigns using such data points. So, I mean, in terms of like mobile malware, you can like say that an APK signing certificate is definitely one, as just mentioned by Christina. There could be some classes that could be shared by malwares. So some classes of the Android source code, and some might be like related to surveillance capabilities, like exfiltration of specific data. So they might be trojanizing different applications, but might be using some portion of their source code. They might be also sharing some specific strings, right? It could be something around like threat infrastructure. So they might be hard coding some kind of IP addresses, or some domains, right? As in this case. And similarly, like they might be also in general might be using threat infrastructure, so reusing connections to same IP address. So like as Krishna said around the dynamic analysis engine. So using that kind of engine, we are able to, if the infrastructure is hidden in the source code, then using the dynamic analysis engine that we have, we are able to find the infrastructure and see if something is being shared from across the different malware campaigns. So other than that, I would say like there are also like open source spywares or commodity spywares, which these kind of actors could find on dark web or criminal forums, and might reuse some component of those open source or commodity malware in their custom malware. So they might be using some portion of like Android Rat, Spy-Note malware family. So these are all like known commodity spyware families that these APT actors tend to reuse and share, right? So there are like multiple like Android, Spy-Note, Droid Watcher, SpyMax, and CypherRat. Now, the reason again, like as mentioned, they have to scale their operations, right? They have to quickly scale their operations. So that is one of the reasons they have to limit their forensic evidence. So more code you write, more patterns you leave, and you can get detected. So you can share something. So it would be hard for a researcher to create a detection or make attribution specifically to an actor if it's actually shared across everywhere, right? Or by others as well. And in the end, it's also like financially, it becomes cheaper. So if you are making a custom software of your own, it becomes cheaper if you are able to reuse some of code from the past.
So
So
what
yeah,
I'm hearing is, yeah,
go
they're
ahead.
not so different from us.
Yeah. Yeah,
Except they're
humans. Not
just
aliens.
criminals, that's all, you know. So actually, and then this one actually just came in while you were answering that part. Thank you. Maybe for Christina, what is a Dalvik file? Pretty straightforward question. I actually wondering that too. I never heard that.
Sure. So the Dalvik executable here is the, in this case, we're talking about an executable file that's running within the virtual machine of the Android environment. If you're looking at, say, an Android application and you pull it apart, because an APK, or that's the package name of or the file type, I should say, of an Android application. When you pull it apart, it's kind of just like a zip file, and within that you'll see a file that is with the file type .dex that is indicating that it's a Dalvik executable file. So here we're looking for samples within the dynamic analysis engine that have returned executable source code that fit as into that Dalvik environment.
Awesome. Cool. All right. As you were. Thank you both.
Sure. Okay, cool. So we've got 2 samples here that have come back. This is exciting. Again, as a researcher, this makes me really happy because anybody watching this who comes from like a malware analysis or threat research background, sometimes you come across really interesting malware samples that you're seeing a little too late in the game. So maybe you've acquired something, but the infrastructure is down, the C2 is down. So even if you're trying to run it within a virtual environment to see what it's doing, who it's how it's talking to its command and control infrastructure, what it might be acquiring from that command and control infrastructure. If the infrastructure is down, you probably aren't going to get anything. And that can be really frustrating. So this indicates that we have 2 samples here, at least, where our dynamic analysis engine was actually able to find a sample, run it in an emulated environment at a time when the infrastructure was still operational. So if we hop in here, we can go to the dynamic analysis tab, and we can see, all the information that we get back from that, the dynamic analysis of the sample running on our emulated device. And then, for premium members, you can actually chat with us. We can get access from the researcher side to things like the secondary payloads that are required, and I can kind of fill you in on what that looks like. But we get a bunch of details here from that dynamic analysis engine about how the communication with that malware looked, and what the network traffic was like, and all that good stuff. So the last thing I want to show you quickly is if we hop over to behaviors. I talked about capabilities and how we can kind of pivot from samples like this to find something that could also be malicious within our data set. So we've looked at this sample of DragonEgg. Up here you can see it's masquerading as Telegram. Clearly this is not the legitimate version of Telegram, but we often see surveillance tools masquerading as social media applications, primarily because they can request a bunch of permissions that you wouldn't typically grant to something like a flashlight application. And so they're able to kind of convince users to be more trusting than they might otherwise be. So if we hop into our capabilities down here, we can pivot from any of these, but let's click on record media. Let's expand this a bit. We're going to see a whole bunch of samples that come back saying that they record media. Again, the vast majority of these are not going to be malicious, but we can continue adding capabilities and find something that that really is using all of the various capabilities we would consider suspicious. And then let's break it down and look for something that's also masquerading as Telegram. So we can say access, got the quote, access camera, capabilities, capability type, record audio is a good one, capabilities, capability type, read location, capabilities, capability type, receive SMS, capability type, contains dynamic code, just like our last sample did. And then actually let's look for, I think that's probably good. Let's also look for something that has the title of Telegram. So here we say title.value. This is our way of specifying we want an application that says its title is Telegram. So let's see what we get back here. Now, again, we're likely going to see some applications that are very clearly not the legitimate Telegram application. See, we have a package name that says com.samsung.radiocloner. This one is typically a package name that's used by a particular packing tool, just basically obfuscates the code or makes it more difficult to look at the source code. We can see the AMIF open source surveillance tool here. We have a detection for that. We can see the use of Metasploit. SpyNote is another very well-known commodity malware that we're seeing detected here. So we kind of get back a bunch of things that look quite sketchy and are masquerading as Telegram. So this is a really interesting way to look through your data set and see what malicious stuff might be trying to masquerade as something legitimate. Great. Okay, so that's the end of our demo component. Hank, I'll pass it back to you.
Yeah, great work, Christina. As always a pleasure to watch you go through this stuff and learn about what you guys are doing in Parth. Thank you for all your insight here. And folks, we are running up on time. So if you had any questions that didn't get answered, I'm sorry that we're not going to be able to get to them. But I hope today was interesting and helpful. And we talk a lot about sort of the importance of mobile and mobile surveillanceware and the growth of these commodity malware families and how they're contributing to more growth of just more advanced mobile surveillanceware that we're seeing. We focused on Android today. Obviously we see this on iOS as well. That's a whole other conversation, I think. But before you go, just one thing that I'm just going to flash up on the screen here real quick is an example of actually something we have on our site that you can go find and download. I think we'll probably share it out afterwards. But so one thing that Parth, Christine, and their team work on every month is, let me zoom this out a little bit, is a monthly threat report, right? So this is one that we have actually on the website that you can take a look at, where what the team does is they basically pick, usually, what would you say, guys, between like 2 to 4 families that you're tracking each month, and do a real deep dive on them. Really go through, the history, the attribution, the capabilities, the infrastructure, the IOCs. I mean, just everything you could need to feed this into, your existing, threat hunting flows that you may have, in your organization already. Folks across, SOCs and, security analysis teams and things like that find this very interesting, very helpful. The other thing that I will mention is that these reports, which come as part of our threat intelligence services, offering and is in our MES premium package, while we protect everyone from malware as we discover it, regardless of whether you're a lookout for small business user or one of our top tier government customers, this information, this very, very detailed information, is shared usually a couple months ahead of time, and so that folks who honestly have signed up for the service get first look at it. You're protected either way, but it's just something to keep in mind there. But yeah, so it's interesting. It's pretty cool. And regardless, if you're a current, MES Essentials or Advanced customer, you will actually see very brief, 2 or 3 paragraph summaries of each of these, basically just a plain text overview within your console each month. That's something that we added recently. So again, thank you everybody for joining. Parth, Christina, thank you both as always. And if you have any questions, you can always reach out to us on through the website, on LinkedIn, however you feel like getting in touch. We're always happy to answer questions. And for those of you who did ask questions that we didn't get to, we'll be sure to reach out with answers shortly. So everyone, thank you so much, and we'll see you on the next session.
Thank you.
You.